What if the biggest visitor of our lives never shows its true face? What if 3I Atlas is more than ice and dust, something Clarke would recognize? We'll never know for absolute certainty, because unlike Clarke's story, we don't have a crewed mission ready to chase it. People like Harvard's Avi Loeb have speculated about a technological origin, but let's stick to the facts. Let's stick to what we can prove. What do peer-reviewed papers actually say about this interstellar traveler? In this video, we'll compare the facts to fiction and see where Arthur C. Clarke's Rendezvous with Rama and 3I Atlas line up. It came from the unknown, from deep space, a visitor from the stars. They called it Rama, a seamless cylinder 50 kilometers long and 20 wide, rotating to form gravity against its inner skin. The solar survey ship Endeavour catches it, its fusion drives enough to match Rama's speed. A small human crew lands and discovers its way into the alien craft's hollow world. Land curving underneath and overhead, a dark, cylindrical sea, silent towers, and tireless biots, self-repairing biological machines that tend everything and notice no one. The crew map, measure, and listen. Rama offers patterns, but not meaning. Function without welcome. Utter indifference. As sunlight warms it and it draws nearer the sun, the great machine awakens, systems brightening, winds rising, yet it never speaks. No greeting, no threat, just its own destiny and purpose that has nothing to do with us. The crew leaves with good data, but changed hearts, awed by scale, humbled by indifference. Behind them, Rama leans into the sun, takes its gravity slingshot and launches into the dark, still beautiful, unknowable, and gone on its way forever. Arthur C. Clarke's 1973 novel is our sounding board, our comparison. How does 3I Atlas stand up to his classic story? This is 3I Atlas, C 2025 N1. The third confirmed interstellar object we've seen in our solar system. Its path is hyperbolic, meaning it's not bound to the sun. It dives in, swings by, and leaves far behind, heading out for deep space. Translation: it isn't from here, and it's not coming back. Atlas. The survey in Chile found it. 3I Atlas races through space at tens of thousands kilometers per hour. The sun bends its path, but can't keep it. It's too fast. From the first images, it felt familiar and strange. Some data looked like a normal comet. Some didn't. Our plan? Pull out the strongest peer-reviewed clues. Can nature explain the weird parts? Or is there a hint of Rama in the record? Unnaturally natural comet-like weirdness. 1. A quiet but clearly interstellar start. 2. A wobbling jet that reveals the spin. 3. A sun-facing anti-tail made by unusual but natural chemistry. The third one changes the stakes. Before we dive in, your take? Drop a comment. Engineered visitor or very weird but natural comet? And please like, subscribe, and share. It really helps. In Rama, the orbit screams outsider. Same feel here. 3I Atlas has an eccentricity than 1. That means it's on a flyby, not coming into orbit. Its approach speed is about 58 kilometers per second inbound to the sun. That combo is a clear fingerprint of a visitor from another star. We didn't make it. Our solar system didn't either. The question is, who or what did? Because it's simply passing through. Rama arrives quiet. No radio calls, no engine roar, only clues. Early peer-reviewed analysis of 3I/Atlas carries the same mood. Telescopes saw a low-level coma with a deep red color slope, redder than most comets. Yet the usual gas lines were faint or missing at first. That points to space-weathered organics and a crust cooked by time, likely shaped under another sun or in the dark between stars. Not a metal hull, just alien weathering. But the feeling is the same. Lean closer. In Clarke's story, spin matters. For 3I/Atlas, geometry does the talking. A thin, high-latitude jet, a geyser of dust and gas near a pole, changes the rotational angle on a regular schedule. Think of a tilted sprinkler. The swing repeats every approximately 7.74 hours. If one near-polar vent causes it, the full rotation is about 15.5 hours, 2 swings per turn. This wobble also pins down the spin axis direction on the sky. It's the first periodic jet angle wobble ever seen in an interstellar comet. In Rama, the craft maneuvered toward the sun. 3I/Atlas behaves similarly, but with a sun-facing anti-tail. Most comet tails point away from the sun. An anti-tail can look like it points toward it. Often that's a camera angle trick. But new modeling says 3I/Atlas can make a real sunward bright streak if CO2 outgassing lifts water ice grains that last longer on the sunward side. The shape feels deliberate, but that's chemistry and physics, not alien-designed thrusters. Let's get deep into the science. Clarke's astronauts go inside Rama. We can't do that here. We study what leaks, what we can see exiting from it. Enter JWST. At about 3.3 astronomical units, between the orbits of Mars and Jupiter, NIR SPEC saw a CO2-dominated coma with approximately 8 times more CO2 than water, among the highest ratios ever measured. It also saw H2O, CO, OCS, and even water ice with outgassing stronger sunward. Why so much CO2? 2 natural ideas. Born cold, it formed in a CO2 ice zone around another star where CO2 freezes, but much water does not. Processed by space. Long exposure to UV and cosmic rays can drive off or break down water faster than CO2, CO, leaving a crust that releases more CO2, CO when warmed. Either way, this is natural chemistry, not tech. Clarke's Rama is a manufactured cylinder. 3I/Atlas is alien in a different way. Polarimetry, reading how light is polarized, suggests the inner coma holds lots of water ice grains mixed with dark carbon-rich dust. That mix is less common in similar comets here. It's a micro-fingerprint from another stellar system. Odd by our standards, but fully natural. Here's where peer-reviewed data echoes Clarke. Unbound interstellar path, the same not from here entrance as Rama. Quiet start, red dust-led glow, weak early gas, listen first, then decode. Revealing geometry, Rama via rotation, Atlas via jet wobble, spin solved, and a sun-facing outgassing plume that looks planned, but isn't. Alien chemistry, literal, formed under another sun. CO2 rich, ice grain heavy, not our usual mix. These are real parallels, entrance, mood, geometry, chemistry. Now the boundary. Peer-reviewed papers say 3I Atlases is a natural interstellar comet. Strange? Yes. Deeply informative? Absolutely. But explainable by ices, dust, sunlight, and spin. No refereed paper calls it a spacecraft. The wonder stands, an amazing deep space visitor coming from far outside our solar system, but without the hype. Avi Loeb, with Hibbard and Kroll, has argued in non-refereed pieces that 3I Atlas's path and alignments could match a purposeful probe using clever solar geometry. It's a bold thought experiment, not peer-reviewed proof, and no techno-signatures have been detected so far. Treat it as stress testing the data, not a verdict. Put the results together, and a clear picture forms. A quiet, red beginning, an irradiated, organic-rich surface that stays gas-quiet far out. A wobbling jet, a natural metronome giving approximately 15.5-hour rotation and a fixed pole on our sky. A sun-facing structure, not a maneuver, but CO2 power lifting ice grains that last longest sunward. Add JWST's CO2-rich breath and the polarimetry, chemistry and dust shaped under another star, all ruled by nature's physics. Alien in origin, understandable in behavior. Rama taught us that first contact can be quiet, seen in shapes, cycles, and light. 3I Atlas does that for science. It resets expectations for worlds born under other suns. It tests our tools, from Hubble's sharp eyes to JWST's chemical visualizing. And it trains us for the next visitor. Faster, fainter, stranger. The gap between wonder and understanding is readiness. Measure to model, to predict, to intercept. Clarke told us to look up and listen. 3I Atlas shows the galaxy answers, in spectra, spins, and sun-pointing light. Not with words, with physics, and a promise. More is on the way. If you love the crossroads where hard science meets classic sci-fi, subscribe. Drop your sharpest Rama Atlas parallel in the comments. Cite a source if you can, and we'll feature the best in a follow-up.